Welcome to Ship, Sea and the Stars, our weekly online webcast from Royal Museums Greenwich. Every week we're bringing you fabulous stories of history and creativity, culture, sea and the space, all sorts of things, with Royal Museum Greenwich curators and special guests. And if there's a question that you'd like answered or something you'd like us to talk about, do please get in touch. You can find us at Royal Museums Greenwich on Facebook, Instagram or Twitter, and we really would love to hear from you, so please do get in touch. Today we are talking about time. The Royal Observatory in Greenwich was founded on the 10th of August in 1675, so its birthday is coming up. So we thought this would be a good topic for this episode. And of course, the Royal Observatory is the home of Greenwich Mean Time. It's a place where for hundreds of years, astronomers have looked at the skies to help them measure both what's outside Earth and to keep time on Earth. And it's very exciting because the observatory has, just after lockdown, reopened to visitors, so you can go and see it for real now. But in case you can't book your tickets yet, or in case you live too far away to visit, we thought we'd give you an introductory exploration of the subject of time. And we've got three fabulous experts to help us on that journey. And they are Louise Devoy, who is the curator on this topic at the Royal Observatory, Ed Bloomer, who is a Royal Observatory astronomer, because they do have their own astronomers still, that's very important. And we have Steve Taylor, who is an author and senior lecturer in psychology at Leeds Beckett University. Now we're going to start, as always, with an excerpt, and this one is a very, it's quite an old excerpt. It's from Shakespeare's History, Henry VI, Part 3. And the context for this piece is that Henry has just been told there's a battle that is about to start, or that's going on. Henry has just been told by his wife Margaret that, frankly, the most helpful thing can do is get out of the way because she does better without him. They basically said to him, we're all fine, we'll get on with the battle, you go and sit on your hill. And he is sitting on the hill and meditating on the nature of time. And this excerpt is read by Simon Kane, and actually Simon suggested it as well. So here we go.
O God, methinks it were a happy life to be no better than a homely swain, to sit upon a hill, as I do now, to carve out dials quaintly, point by point, thereby to see the minutes how they run, how many makes the hour full complete, how many hours brings about the day, how many days will finish up the year, how many years a mortal man may live. When this is known, then to divide the times. So many hours must I tend my flock, so many hours must I take my rest, so many hours must I contemplate, so many hours must I sport myself, so many days my ewes have been with young, so many weeks ere the poor fools will ean, so many years ere I shall shear the fleece, so minutes, hours, days, weeks, months, and years passed over to the end they were created, would bring white hairs unto a quiet grave. Oh, what a life were this! How sweet, how lovely.
So it's a fascinating excerpt because this is a king wishing he could count time like a shepherd. And there's something in that which is very democratic, that time, kings have it and shepherds have it, but what they do with it is quite different. And it was written in around 1591. So this is, it's been around a long time, this idea of thinking about time passing. So what are the reactions from all of you? Louise, let's start with you.
Yeah, so just thinking about shepherds, that reminds me of some of those little shepherd's dials that you can get, these sort of cylinders with these wavy lines on them that you can use to tell the time according to the seasons. And you can have everything from the basic wooden version that an ordinary shepherd would have had, all the way through to a deluxe version made out of silver or ivory that perhaps a king or someone else might have used. So the same instrument but used by many different people. That's what it reminds me of.
I didn't know about that. I'm going to have to go and look for, next time when the museum opens, I can go back and look for one. Ed, how about you?
Well, there are lots of things that sort of jumped into mind. I mean, one thing is, although you're talking about this being quite a universal idea or sort of experience, we also sort of record time in different ways. And certainly we've been recording time for a lot longer than from the origin of that writing. So it's quite interesting, even the idea of thinking about things like seconds and minutes and hours and days and months, all the different calendars that we've had throughout history and throughout the world. And then also the idea of sort of maybe even trying to move beyond that and divorcing it from human experience into something that, you know, we try and think of it as being a bit more objective. So it's interesting. There's a lot going on there, I think.
It's interesting because he adds it all up and then he divides it all out. It's
yes.
You know, in a different way. It's a very mathematical piece. Steve, how about you? What do you take from that?
To me, it represents a couple of things. One is that time is a kind of mental experience, that it's a human creation. We create time through thinking about time. You know, we divide our days into seconds and hours through the human mind. You know, there are some aspects of time which obviously exist outside the mind, like days and months and years, you know, but things like seconds, hours, they're human creations, and we create them by thinking about it. And the other thing is that it's quite an unusual passage for Shakespeare, because he's normally very pessimistic about time. You know, he talks about time running out, our lives being short, and so forth. So it's quite unusual for him to have a more kind of optimistic or rosy view of time.
Even in a slightly depressed king on a hill who's just been told he's a bit useless.
Yeah.
I just find that very funny. Okay, right. We're going to start this week, you know, with the observatory, because we have to and because it's awesome. And Louise has a fabulous object for us, which is slightly unusual. Tell us about this, Louise.
Yeah, so this is the Shepherd Electric Impulse Clock, and it's all about sharing and coordinating time. So the fact that we've all agreed to meet up at the same time and have this conversation is pretty much thanks to this clock, actually. It may not look like much, but it really changed the whole way that we think about time and how we use time in our daily lives. It dates from 1852, when it was installed at the observatory. The inventor, Charles Shepherd, had shown off this amazing idea at the Great Exhibition a year before in 1851. And the astronomer royal, George Bidlary, saw this clock and thought, I think I can use this. So this clock was used to distribute observatory time, Greenwich Mean Time, across the country via a series of telegraph wires.
So this is an electric clock. So up till then,
yes.
all the beautiful clockwork of Harrison and, you know, the many amazing clockmakers, this is a step on because it's electric, which is that's the big idea, right?
Yeah, and it's sending these electric impulses so that you can keep all the other clocks that are connected to it in sync, in perfect sync. So even though you've got this one clock down in the basement in the observatory, out of sight, completely invisible, it's controlling all of these clocks all around the country. It would send out signals once an hour to, say, the clocks in the London railway stations, or it might send a signal once a day to other clocks in Edinburgh, Belfast, Hull, wherever. So it really was sort of this beating heart of this brain that was controlling clocks all around the country. And so
did people get on board with that straight away? Because, I mean, it sounds brilliant to us now, I guess, that, suddenly I know what time it is in London, but perhaps people in Birmingham didn't want to know what time it was in London. Did everyone think this was a good idea, or was it an idea ahead of its time?
Yeah, good point. So we're used to having sort of the same time and just not questioning it. But before this clock, people often use their own local time. So your church clock or your town hall clock will be set to local time, which might vary by about 12 or 20 minutes, depending on where you are in relation to Greenwich. And that was fine if you're just living and working in that area. But once you start to travel across the country, it's a lot easier if everyone's using the same reference time. And so the railways started to use Greenwich Mean Time. And then gradually people started to use that as their sort of everyday time. And it became our civil time in 1880.
And the time's actually visible if you walk up to Greenwich. You can still see, I don't think it's the same clock, but you can still see the time in the way that they would have been able to. There's a clock outside the observatory.
Sure. Yeah. So if you go up the hill and you can see it just on the gates, the Royal Observatory, there's the Shepherd's Gate clock. So this was originally connected to that main clock and would have received those electric impulses So this was a very visible demonstration of Greenwich Mean Time. It's quite difficult to read because the dial has actually got 24 hours rather than the usual 12. But it's a great way of showing Greenwich Mean Time. And as you mentioned, if you go to other places in the country, some of the clocks still have Greenwich time, but also their local time combined, so that people could choose whether they used local time or Greenwich. So interesting to see that sort of cultural legacy in our clocks.
I also really like the democracy in a way of the combination of the shepherd clock inside and the shepherd clock outside, because inside, I guess, if that's the time reference, that's the important thing that the scientists use. It's the formal recognition of time. But just outside the gate, you know, Joe Bloggs can just walk up and see exactly the same time. And
Exactly.
it's really democratic. The idea of displaying it in that way is really interesting, I think, because it's sharing it. It's not saying, oh, this is our time, you can all, you know, have your inferior local time. It's very democratic.
Absolutely, and it went even further in that there was also a service where someone would come to the observatory every Monday. They would set their accurate chronometer to that time, and then they would carry that time all around London to various businesses who had a subscription. So that was an even more advanced way of displaying the time and sharing it with people who needed to know it in detail.
And how did they keep it in check? Because obviously clocks do drift. And you can imagine this is a clock, you don't want this one to go wrong. So right back when the Shepherd's electric clock was used, who decided whether it was right or not?
It was based on observations made with the Airy Transit Circle. So this is a telescope that you can still see on display at the observatory today. So you'd measure the time from the stars, you'd convert that into your clock time, and then they would use that to check the Shepherd clock and all the others in the observatory. So the astronomers were constantly checking against what was happening in the sky as well.
And then just briefly, how did that spread outwards? Because, that's all right if you live in London and the person on the horse can turn up with the special clock that, is checked. What was the story of that spreading out to other places?
It's really the story of telegraphy. So all of these telegraph wires extending across the country, that's how you would distribute the signals. And then from the 1860s onwards, you've also got these submarine cables under the Atlantic. So you could then test your signals against observatories in the States, or they did experiments checking their time signals with observatories in Lisbon, India. So it becomes really sort of interconnected.
So we start this world of time being the same everywhere. And since then, clock technology has obviously moved forward. And I think it's really interesting, actually, that we take for granted now that somebody always knows exactly what time it is. But measuring exactly what time it is and keeping that time isn't necessarily straightforward. But Ed's got two objects to show us, which tell us how it's done today, but they were some earlier versions. Tell us about these, Ed.
Sure. So what I'm interested in are the atomic clocks. And this is a slightly odd thing because prior to atomic clocks, we had that human connection, certainly to timekeeping, and we would have references to what was going on. We use astronomy. Atomic clocks slightly represent the divorce of the human self, perhaps in some ways, from timekeeping, because we're moving from checking things with astronomy to really dealing with time as an atomic issue. By looking at transitions in cesium atoms, we could define a second incredibly precisely. And once you can do that, you can use that as a really, really good reference. So these are clocks that, well, with the sort of current generations, you wouldn't misstep by a second in less than a few 100 million years. And so that's in some ways a little bit more tyrannical rather than democratic, because what you're saying is there's a standard here, and we want to sort of adhere to this, and it's certainly much better than any human is going to sort of check. It's still somewhat democratic in that there are lots of atomic clocks around the world, and they share time, and they agree on something. They sort of vote.
Well, let's get on to that, but let's look at these clocks first.
Sure.
Because these are from the these from the 50s. How old were these? These are slightly not the earliest ones. This, right?
No. So atomic clocks start coming in the mid 50s. And we're looking at ones, I believe, if we're looking at the right one, we're looking at ones that were used in the 90s. So they're not much to look at from the outside. They look a little bit like hotel safes or something like that. But it's what's going on inside to really keep track incredibly precisely of, well, time itself, as objectively as you can, I suppose, or as objectively as we've managed to do so far.
And how big is this thing? Is it, this is sort of shoebox size, is it?
Yeah, well, I mean, earlier atomic clocks were pretty big things. They looked a bit like filing cabinets, some of them, and then they shrink down, and it depends on how accurate you want them to be, how powerful they can be. So that, I mean, they are getting smaller and lighter all the time as technology marches on. But some of the earlier ones were fairly hefty, to be honest.
So very briefly then, is there any reason for time to change? So you said there's an element called cesium. That element has precise quantities, physical properties that as far as we know, they don't change anyway. If you put a cesium atom anywhere in the universe, this is what a cesium atom does. Does time ever need to change again, or have we've decided that's it and it doesn't ever need to get any better?
Well, that's a good question as to how accurately we can measure it, and there are, we think, some fundamental limits to sort of the distance, if you like, in time between events in the universe. We could have a thing called Planck time. So I suppose we could continue to refine atomic clocks. The benefit of measuring one thing more precisely and more precisely and more precisely is that you can use that as a reference for lots of other things, and that helps you. Not just measuring things like the length of something, that's of course important, but we're talking now more about events both in space and time, and the better you can get your measurements, the more precise you can be about all sorts of different things. Even if we want to take a sort of random example of, scheduling things, if you can schedule things more and more efficiently, you get a better sort of throughput of work, and so productivity can rise and all that sort of thing. So actually, physical measurement of things then leads to all sorts of changes in society about how precisely you can do all manner of things.
I'm not sure my timekeeping is good enough to need an atomic clock, to be honest. But let's go back to this issue of who decides now, because this again is interestingly democratic, and you hinted at it, but tell us how we know what time it actually is with atomic clocks now.
Well, so it's a consensus by atomic clocks housed by different institutions all over the world, actually. They define atomic time. There's also universal time, and that's a way to try and coordinate everything that's going on, if you like, in real life to establish a baseline. The thing is, nothing really stays still, and nothing refuses to change. And so when we talk about things like universal time, we do take into account things like leap seconds, or you can even do it with fractions of a second. The Earth is slightly slowing down, so the day is slightly longer. The year is very slightly changing. We're transferring angular momentum to the moon. And so things are changing there in terms of orbit, if you wanted to do by matching orbits. And none of this is ever anything that anybody worries about on a day-to-day basis. If you're going down the shops, you don't really have to worry about this. But we're progressing with science, and so we want really precise measurements, more energetic measurements. We want to look further and deeper and all that sort of stuff. So we're trying to get increasing accuracy all the time, because, as I say, the better you can do one thing, the more it sort of spills out to, and you can lock other things down. So there is a consensus, but we also then have to still bring in the human element of deciding when to implement changes.
Well, it is. So, I'm a field scientist. So when we're out in the field on the ocean, and it's especially relevant on the ocean, actually, because you're sort of drifting around. We do use UTC, which is Universal Coordinated Time, and everyone on the clock, every ship has a clock, which is UTC, even if it's different to your daylight time. But it's such a useful thing because it doesn't have time zones. So it's kind of similar to GMT. And up near the North Pole, for example, you can literally drift across 3 time zones in a day.
Sure.
You're in the right place. And this gets around it. So all, Earth observation measurements everywhere in the world are made on UTC, so that we can be sure that no one's got their time zones wrong. And it's such a simple thing, and yet it is really important. And let's move on. So we live in a world where, there's all this fabulous accuracy in measuring time, and we can keep track of all of that in very democratic ways, but we are still messy humans, and we're late for things, and we don't really know how our brains work. And so we're basically the same biologically as we were before any of these clocks were invented. So how does time work for us? Now, Steve, you've got an object for us that highlights some of these issues.
Mm-hmm. Yeah, as a psychologist, I'm interested in the human experience of time, the way that human beings perceive time in different situations. And one thing that's clear from the human experience of time is that time is not fixed. It fluctuates continually. Every day we may experience several different variations of time perception. So this image represents two different situations where time becomes elastic. And one is that you could call this the "Are we nearly there yet?" chair.
So this is a children's. It's a car seat for a child. Anyone who didn't recognise it.
Yeah, that's a phrase I've heard many times from my kids. Are we nearly there yet? And for me, it represents also the first time I began to think about time perception, which is when I was a child, we used to go to North Wales for our holidays every year, and the journey took 2 hours back then. It's slightly shorter now. But back then, I always had this memory of being in the car for what seemed like hours, endless hours, and getting incredibly frustrated and impatient. And years later, when I was an adult, when I was 30, my girlfriend and I went to the same place in North Wales, to Conway, for a holiday. And it took us, in real time, an hour and a half. But to me, I thought back to when I was a child, I thought, wow, this is such a different experience of time. These endless hours when I was a kid seemed to pass incredibly quickly. So it made me realize that as a child, I had a much slower perception of time. And I think that's true. Children have a much slower perception of time. So what seems like, what is 24 hours to a child is actually a much more extended period than it is to an adult.
Well, we're seeing that now, isn't it, in lockdown, where kids especially, for if you tell a 10-year-old that you can't do something for a month, that's an eternity. And adults like, a month goes by in a second. What are you talking about?
Yeah. I also have a very strong memory of when I finished primary school. I remember thinking, wow, I've got to go to the secondary school in 6 weeks. Should I worry about it? I thought to myself. And then I thought, no, I'm not going to worry about it. It's so far away that it's not even worth thinking about. So I remember thinking that those 6 weeks was such a massively extended period, probably more like 6 months to me now as an adult. So as a psychologist,
how do we study all of? So how do we get at how you perceive time? Because you can imagine there's an atomic clock, and you can kind of, there's little electric signals that tell you what's going on. But for a human, how do you work out how we perceive time? How does all of that work?
Well, it's subjective. Experience of time is subjective, so it's kind of difficult to measure it in an empirical sense. But the second way in which the second thing that car seat represents is accidents. In accidents, it's incredibly common for people to experience a massively extended period of time. So what is in real time a few seconds can seem like a few minutes in an accident situation. So there's something about, this could also happen in certain altered states of consciousness, for example, psychedelic experiences, which obviously I have no experience of myself. Also deep states of meditation and so on. So a lot of altered states of consciousness feature an incredibly extended experience of time.
And do people seek out those experiences because of what they do to time? Is that part of the attraction, or is it a sort of side effect, or is it something that people deliberately kind of seek out in some way?
Well, I think meditation is a good example because, there are different varieties of meditation. A lot of people these days practice mindfulness. And there's a lot of research suggesting that mindfulness has a time expanding effect. That people who've meditated for a long period of time, they experience more time within an hour, for example, than other people do. They kind of overestimate periods of time in empirical tests. That's one example where there is some empirical evidence for time perception. So I think, people sometimes, maybe one of their motivations for meditation, for example, is to experience a high degree of presence, which has a time expanding effect.
And do we think that it's useful? Is it sort of a quirk of the human brain that, it just does that? Or is there some, is there something you can do that's actually useful to you, helps you survive the car crash or something? Or is it,
that's one of the possible explanations. These experiences are quite mysterious, but one possible explanation is that they are a kind of evolutionary adaptation for accidents and emergency situations. Because one of the things that I found in my research is when people have these time expansive experiences in accidents and emergency situations. They feel that they have more time to respond. They have more time to react, to position themselves, to take evasive action. And it's not just an illusion. People actually do manage to, land in the right place where they minimize the damage to their bodies. They have more time to adjust the pedals or the steering wheel of the car. So it's not just an illusion. It does seem to have a kind of survival enhancing effect.
So that whole thing in Crouching Tiger, Hidden Dragon, all of those, that actually might happen might be a real thing to some extent without the fat swanky 3D sort of effect.
But yeah, I mean, that's another interesting application is martial arts and sports. A lot of sports people say that in peak moments, that time, when they're in the zone, as it's sometimes called, time slows down so that they have more time to position themselves, more time to respond to people's movements and shots. So, and I think in certain martial arts, people actually consciously cultivate this slow down sense of time to give them a mental advantage and also, a competitive advantage over their opponents.
It's interesting how it does come up in popular culture, doesn't it? Even, if you think about Star Wars, there's plenty of examples where it's seen as a special power, to be like the ultimate power is to be able to slow down time in some way. And it's coming up in human culture. So
it is a special power. I often think that there are certain athletes and sports people who are just so far beyond everybody else. They're just on a kind of level above everybody else. And I think, it is something to do with time perception, that these people have a slightly slowed down time perception, or they have an ability to enter the zone consciously, and that gives them the advantage of greater time to position themselves and to respond.
Okay, brilliant. So we'll continue that when it comes to your second object, but just for anyone who's joining us, this is Ship Sea and the Stars from Royal Museums Greenwich, and this week we are exploring the nature of time with Louise Devoy, Ed Bloomer and Steve Taylor. Now we have a reading to start the second half, and it is an unusual reading, but I think it's worth listening to. We know when we think about the history of the discoveries that make up our idea of time that relativity is in there somewhere. Einstein and this idea of space-time, it's all in there. And this reading is the final paragraph of Einstein's fourth paper on general relativity from 1915. And this is the paper that ties up all the loose ends. And you'll see he admits this in the final paragraph, that this is the one where he's finally got it right. All the jigsaw pieces have fallen into place. He's worked it out, and he knows he's worked it out. And as a note, it is perfectly fine if you don't understand any of this. But I think it's interesting to listen to because there's all these ideas of time, and yet the study of it can be quite esoteric. So don't worry if you don't understand very much, but I think it's worth listening to. This is the final paragraph of Einstein's 1915 fourth paper on general relativity, and it's read by Simon Kane.
With this, we have finally completed the general theory of relativity as a logical structure. The postulate of relativity in its most general formulation, which makes space-time coordinates into physically meaningless parameters, leads with a very compelling necessity to a very specific theory of gravitation that also explains the movement of the perihelion of Mercury. However, the postulate of general relativity cannot reveal to us anything new and different about the essence of the various processes in nature than what the special theory of relativity taught us already. The opinions I recently voiced here in this regard have been in error. Every physical theory that complies with the special theory of relativity can, by means of the absolute differential calculus, be integrated into the system of general relativity theory, without the latter providing any criteria about the admissibility of such physical theory.
So it's an example of how complicated the study of space and time became even more than 100 years ago when Einstein first wrote that. And I wasn't mean enough to ask Simon to read it out, but the final equation that sits just above that paragraph is so short. And yet it only makes sense if you understand four-dimensional tensor mathematics. It's really elegant, but it's also really complicated. So it's often thought that general relativity is just one of those things that exists somewhere, it keeps the physicists happy and quiet, and it basically doesn't matter very much to the rest of us. But actually, that is not really true. And Ed is going to explain to us why that is with his next object. So Ed, show us what this is.
Sure. So this is a picture taken on the the meridian line at the Royal Observatory Greenwich. This is a handheld GPS receiver. So it's getting signals from GPS satellites to determine its position very accurately. This is actually only from the mid-90s. Civilian access to GPS is really only a few decades old, and it's, I would say, probably indispensable nowadays. Everybody can pull out a phone and access this sort of thing. They don't need specialized handheld devices such as this one anymore. But in terms of things like general relativity, why this is important is that general relativity, and there may be 100 people that want to sort of shout at me if I say something like this, but general relativity essentially sets up a framework by which you can understand the universe. Einstein's talking about in his last part that everything he did with special relativity works in general relativity, because general relativity just tackles everything, not just the special cases. I don't think he's correct when he says that nothing else special comes out of it. It's just a bunch of differential calculus. That's not true. He hasn't foreseen the next century's worth of developments, especially with things like black holes, which have these extreme cases. But with regards to GPS, it's still an important issue, because the space-time itself, so we have to sort of imagine that we're not just thinking of time as separate, but it's part of four-dimensional space-time, passes at different rates depending on what's going on. And what's going on itself depends on a million different things. But with regards to GPS, it's the speed of the satellites themselves as they're whizzing around in orbit, and also the gravitational pull of the Earth. And that means that they lose, they gain time. Problem of relativity is it depends on which observation point you're talking about. So let's say they gain time.
The time is passing more slowly on a satellite than it is on Earth. Is that the way we would see it?
Yes, this is a really very small fractions of a second. But if you're bouncing around signals, electromagnetic signals traveling at about 300,000 kilometers per second, if you have a small fraction of a second difference, that equates to a big physical distance shift. And so if you want precise physical measurements of your distance, you want precise time measurements. So if you want to know where you are precisely on your boat, you need to know timing mechanisms very, very precisely. And so already, even though we do think, as you said, that sometimes we think of relativity as being a thing for the scientists, and it keeps us happy, and it does. But in a practical sense, you have to take this into account, and it's already been taken into account by sort of the modern world. The systems of the modern world demand that it's incorporated into them. Otherwise,
the thing here is that the errors add up. If you switched off, if you stopped this correction, everything would drift, and it would only be a day or two before nothing, you wouldn't know where anything was, and because it adds up over time as the two systems become more and more mismatched if you don't correct for general relativity.
Yeah, absolutely. And it doesn't take you too long to wander off a steep mountain path before that's a very dangerous issue. So these are not just academic issues. If you're doing exploring, if you're trying to navigate through shallow waters or beside rocks, it's a very important thing to be precise.
So of course, lots of the work that was done with Greenwich was to do with the calculation of longitude. It was a navigation problem for which you needed time. But even now, as we go on into space, you still need clocks on satellites, on space probes, if you want to keep an eye on where they are. And Louise, you had something to mention about how NASA is measuring time in space.
Sure. So the satellite navigation network that Ed was talking about relies on having a sort of a sense check every day. So some time signals sent from atomic clocks on Earth that you could then use to check and to calibrate those clocks that everyone like yourself in the field is really dependent upon. But once you go beyond the Earth's orbit, what do you do then? It's really hard to sort of try and do that. So the most sort of up-to-date atomic clocks, they're based in laboratories, they're huge, big, bulky. There's no way you could get those onto a space probe without a lot of money and technology. So NASA scientists, I believe at the Jet Propulsion Laboratory, JPL, are developing this deep space atomic clock. So this is a reduced version of these sort of high-tech lab versions that could then be put onto the probes and used further out into space without having to rely on these sort of signals from Earth to check and calibrate them. So really incredible how to take that technology and miniaturize it into something that could be used millions and millions of miles away.
Right. Okay, well, let's go back to the humans and the question of whether time can sometimes go missing. So, Steve, you've got something that can tell us about this.
Yeah, this is a book. It's actually the book I wrote about time, appropriately enough, but it could be any book. It could be any book by any author, because to me, there is a strong connection between the experience of time and states of absorption or states of non-absorption. So that's one of the ways in which time is very flexible. So one thing I find when I'm writing is that sometimes it's a struggle. You know, sometimes I sit down to write and I just can't get into it. And I look at my watch or look at my phone, and time seems to really crawling by. Like an hour seems like 5 hours. Sorry, the other way around. No, that's right. An hour seems to be stretched out indefinitely. And then, something happens. I get into a state which psychologists call flow. I seem to latch onto something inside myself. And it becomes incredibly easy. I write, 1,000 words in a couple of hours in real time. And I can spend the whole day, I can spend 5 or 6 hours in this state, and I can write, a lot, like a whole chapter in a day on a good day. And then, at the same time as being incredibly easy, I realize when I get to the end of the day that time has passed incredibly quickly, that 6 hours has gone by. But in my experience of time, it's more like maybe 1 or 2 hours. So time seems to disappear. It's as if I've stepped into a time hole. And I think part of the reason for that is awareness. When we lose awareness of time, and when your attention is wholly focused in an activity, or it could be some kind of entertainment, which is very intensely absorbing, then time disappears. Awareness of time makes time kind of extend and go slowly, but becoming unconscious of time makes time disappear.
And does that bother humans? Because we know that if you you can disorient someone by, I'm not suggesting you go around kidnapping people, but there's this thing that if you put a bag over someone's head, you take them somewhere, and they arrive, and not knowing where they are is really like uncomfortable. It's disorienting. Do people have the same thing with time, or do we not mind as much?
No, it's the other way around, really. Being unaware of time is actually a very pleasant experience. I think that's partly to do with the tyranny of time, I sometimes call it, the way that, we're always conscious of time, we're conscious of appointments, we're conscious of running out of time. So to forget about that is quite a pleasant experience. And also the state of being in flow, the state of being thoroughly absorbed in an activity is a very pleasant psychological state. It's one of the most pleasant psychological states that human beings experience. It's a state of intensification of mental energy, very sharp focus of attention, and that seems to produce an enhanced state of well-being inside us.
So what does it, because obviously the first question that in the modern world, and maybe all these are problems of the modern world, is distraction. That we live in a world of beeps and alarms and people telling us to do things. Is there a connection? What do we do as modern humans with these two things? That we've got this brain that likes that state, and then we've got this world that tries to take it away from us.
Yeah, it's certainly one of the issues in the modern world, that because there are so many different devices competing for our attention, we're continually shifting our attention from email to texts to real conversations and so forth, that it's kind of getting rarer that we have the chance to really focus our attention and get into a state of absorption. But I think at the same time, I think people are realizing that, I think people are, there is a connection between feeling dissatisfied and flitting your attention around to different objects. Focusing your attention is one of the most pleasant human activities. And, hopefully people at some point will turn away from this eternal flitting of attention into a more focused and a more absorbed form of activity.
So what is your, briefly, because I imagine the answer to this could go on for a while, but if you were a time therapist or whatever one of those might be, what would your advice be to a human dealing with, how do we deal with time? What should we be doing?
Well, I mean, most of us want to expand time. Most of us want to, live through as much time as we can, which means essentially slowing down our time perception. So I mean, one thing you can do is to expose yourself to unfamiliarity, as many new experiences as possible, because unfamiliarity expands our perception of time, which is one of the reasons why children have an expanded sense of time, because the world is so unfamiliar and so new to them. So that's one thing, just make sure that your life doesn't become too stable, too repetitive.
This is mean to tell people this in lockdown when we've all seen the same rooms. It just occurred to me, it's probably a terrible question.
Yeah. Well, this is where the second thing comes in. Which in the second thing, you don't need to go anywhere or to do anything new. You just need to change your experience of each moment. And this is the connection to mindfulness. Mindfulness expands time. That's been empirically shown by research. And mindfulness means essentially paying attention to your experience as it unfolds in each moment. So it means paying attention to everything that's around you in this moment, even no matter how familiar it is, you can give your attention to it. And it also means being attentive towards your own feelings, your own thoughts, how you feel in your body, what's going through your mind. So an attitude of mindfulness, that also is a way of expanding and slowing down time.
Well, I'm sure everyone can bear that in mind. So don't rush off to do lots of busy things after this. Appreciate what you're up to. So we're gonna move on, and it's an interesting link, because I think there is this thing that just awareness of time. To go back to the science, when the microscope came along, scientists saw that there were things that were too small for them to see, and when high-speed photography came along, scientists saw that there were things that were too fast to see, and both of them were revolutions in different ways. But Louise has a beautiful object from the museum's collections that shows a very early example of this. Tell us about this, Louise.
Sure. So this is called a Janssen wheel. It's named after its inventor, the French astronomer Jules Janssen. And so if you look carefully at this object, you can see that it's got 60 little sort of almost like tooth-like marks. And this is actually a sequence of images showing a transit of Venus in 1874. So this is when you have this sort of perfect alignment between the Earth, Venus and the Sun, and Venus appears as this little sort of dot that gradually crosses the solar disk.
So is that the sort of chip that's taken out?
Exactly. So this is a bit like those sort of flicker books that you have as a kid, when you sort of flick the pages and it looks like something's moving. So by having a very sort of rapidly rotating wheel, you can collect the event, the sunlight, and you can almost sort of slow time down and see something that's almost impossible or very difficult to measure with the human eye.
So what's going on here is that we don't generally recommend that people look at the sun, but twice in every 100 and something years, can't just remember how many, it just so happens that the solar system lines up so that Venus is perfectly lined up with the sun. And if you're looking through a solar telescope and you have all the appropriate safety stuff, you can actually see the planet Venus. You can see it's silhouetted against the face of the sun. And so people had seen this, they were aware of it happening, but until the event that this was made for, no one had really been able to measure that, had they?
Exactly. So there was the expeditions in 1769 to view this transit Venus. But the special thing about the 1874 transit was that it was the first one to be seen after the invention of photography in the 1830s and 1840s. So astronomers were really excited that they could use this to really, really precisely measure the exact stages of the progress as the disk, as Venus goes across the sun. And people were keen to measure this because you can use the geometry to then measure the scale of the solar system. So even though visually it's not as impressive as, say, a solar eclipse, it's really vital for our understanding of the solar system. And so by collecting the light, creating this wheel-like sequence to capture it, it's a really impressive way to do that.
And I guess then astronomers, I mean, I've always been amazed at the patience of astronomers. I'm sure with the human perception of time, I'm sure that on cold nights in the observatory, time was passing very slowly indeed for the people who had to wait for the cosmos to go around so they could make very detailed measurements. But it also changes science because you don't have to be there at the moment anymore. you can take your records and then you can wait until it's nice and warm and you can take them back to your office. It changes the experience of astronomy a little bit, doesn't it?
Exactly. So in the 1769 event, people were just sketching by hand. So you had to really make your outline and then try and fill it in from memory afterwards, which obviously produces inconsistencies. Photography, it was still an issue because if you were trying to change all the glass plates, it's really fiddly and cumbersome. At least with this revolving wheel, you can get a succession of images quite easily. But yeah, today we're spoilt. We can take images remotely and then we can analyse them at our leisure.
Well, you could basically put a smartphone on the back of a solar telescope and you would see this. I mean, it's almost embarrassing, isn't it? People had to put a lot of effort in to get there. And I love it. It's also, the reason it's nice to finish on this is it actually brings us back to the idea of celestial clockwork, that the solar system is, very much like, you can always imagine the planets like hands going around a clock. In fact, I think one of my first technology projects at school was I was told to make a clock and I made it with planets going the wrong way around a solar system from memory. But this idea of the cosmos, the celestial nature of time just kind of keeping us in check all the time, and it's quite nice to come back to that. You need to know how big your clock is in a way. That was the question that you asked with the transit of Venus. Okay, so we're almost out of time, but I have one final question to all our panelists, and it is for each of you: if you could only own or use one timekeeping device in history, which one would you pick? I'm going to go first to Ed.
That's a very difficult question to answer. There's so many ideas flood in. I mean, some part of me thinks, an atomic clock of some sort, you could measure more precisely, and that's kind of satisfying. But there's also very historically important clocks, for example.
You can't choose everything. That's not the rule.
Okay, but then I was thinking, maybe I'll be cheeky, and I'll just think, well, I'll just get a really, really expensive, watch. Maybe that would be the thing, because we don't just view it as a mechanical thing. We also to some extent sort of almost fetishize it, in that we produce these beautiful pieces of engineering, and you don't wear them necessarily because you want the most precise. It's because they are lovely things. So there was a part of me that thought, maybe I'll just get a really expensive watch. But for science's sake, let's say a really, really good atomic clock.
So, okay, yes, I think you flaked out at the end there a little bit. We can see where your priorities lie. Okay, Steve, how about you?
Am I allowed to say no timepiece at all?
You are, as long as you justify your decision.
Because I enjoy personally the experience of being free of the tyranny of time, not being conscious of deadlines and future responsibilities. But also, most importantly, I think the most beneficial and positive experience that humans can have is when we are completely in the present. And having a timepiece makes us conscious of the future. So I think, or maybe if you had a watch that just said now on it, that would be quite useful.
I'll take that as your answer, a watch that just says now on its face. Brilliant. Curators out there, it is now your job to find one of these and put it in the museum. Louise, how about you?
Well, I quite like a timekeeper that's a bit difficult to read or a bit quirky, that's not obvious. So I'd go for a really complicated astronomical clock, like the ones at Hampton Court or in Prague. And like you say, I think having that visual representation of all the planets and the calendar and the zodiac, just that reminder that we're part of a bigger clock, and that's really interesting.
I think I would pick a really beautiful sundial, except that I live in England, and so it might not be the most practical clock I've ever had. Brilliant. Thank you all very much. That is so much to talk about. As always, there's far more than we had time for. But we will be back next week with more museum objects and more stories. If you've got a topic that you'd like us to discuss, or you just like to get in touch, do look for us on Facebook, Instagram or Twitter. Look for Royal Museums Greenwich. And as I said at the start, the Royal Observatory is now open to visitors after lockdown. You need to book ahead, but the staff there can't wait to welcome you. So there are a few, the setup looks a little bit different, but the collections are just as amazing. And now you know what to go looking for in there. So you just have to go to rmg.co.uk/welcome back, and there's all the instructions for how to plan a visit on site at the museums now that it's open. So The last thing to do is to thank our fabulous contributors, Louise Devoy, Ed Bloomer and Steve Taylor. Thank you to Simon Kane for the readings, to Steve Thompson for our music. James Gill was the producer, and I'm Helen Czerski, and I will see you next week.